Alright. You all know what time is it? It's time for test review. Mass 2526 test 1 review. Sorry, mass 122 25 slash 26 test 1 review. Let's go from question 1. Question 1 says, which of the following relations is a function from A to B? Option A gives us that, okay, since this is a test review, it's not like the last one. The last one, I was doing past test. The last video I did was past test for last year. So you may not have, you may not know the question, but this one I believe you all already have a question with you. So you can just get your own question. So I'm not need to be writing down every single thing on the board. So question 1, option A, it is 1 mapped to 0, 1 mapped to -1. If you look at it, in the last video, that is the revision video before this test review, I told you how to know how to answer this type of question. First of all, you check. You have to make sure that there is no element in the input that has two outputs. Each input must only be mapped to one output. There is no input that should be mapped to two outputs. And second of all, I told you that to after you have checked them to make sure that there is no input that is mapped to two outputs, you have to make sure that each input is each you have to make sure that each input has an output. I will go over that again. After you have made sure that every input has only one output, each input must have only one output. Second of all, you have to make sure that each input has an output. That is, each input must be mapped. That is, if you are giving a set of 1, 2, and 3, 1, 2, and 3 must have an output. 1 and 2 cannot be and have an output, and 3 themselves. They are a friend. They must all be grouped together, and they must all have an output. Okay. I saw somebody that related this thing well on YouTube on TikTok. The girl was like, you should take Y as a man and you should take X as the woman. Now this is the wrong input, but this is the wrong way of doing it. So what I can say here is that a man can have multiple women, but a woman should only have one man. That's what I can say. A man can have multiple women, but that woman, each of the inputs must only have one man. And second of all, every single woman in the world, that's every single woman in the set, must have a man. No woman should be left out. Every single woman in the set must have a man. But in the set of men, there are some men that will not have a woman. But every single woman must have a man. But there are some men that will not have a woman because some men are having multiple women. Okay, that's how she explained it. So I'm going to use that to solve answer this question. Option A. Let me write it down. This is A, B, C, and D. We'll cancel out. Option A. We have 1 is mapped to 0 and 1 is mapped to -1. So option A is wrong because 1 is mapped twice. Option B. A is mapped to B. B is mapped to C. C is mapped to B, and D is mapped to C. The first thing you need to check is to make sure that each of the inputs only has one output. Like if I check A is mapped to only A, is mapped to B is mapped to once, C is mapped to once, and D is mapped to once. So now the second thing to check is to make sure that every single X value has a Y value. Let's check the X values. The X values are A, B, C, D, and E. But in that mapping, they only map A to D. They let out the letter E. So E is not mapped to anything. So option B is wrong because E is not mapped. Let's go to question C. Option C. Option C now is 1 is mapped to -2, 3 is mapped to 7, 4 is mapped to -6, and 8 is mapped to 1. That is correct. 1 is mapped to only one thing, 3 is mapped to only one thing, 4 is mapped to only one thing, 8 is mapped to only one thing. Now the second thing to check is to make sure that each input has an output. If you check the input set is 1, 3, 4, and 8. And in the set of mapping, the input sets there are 1, 3, 4, and 8. So this is correct. Let's go to C is correct. But let's go to option D now to see what happens in option D. Why is option D not wrong? If you look at option D now, the set of inputs are 1, 2, 3, 4, and 5. That's the set of inputs that are mapped. 1, 3, 4, and 5 are mapped. But if you check the set of inputs, you have 0, 1, 2, 3, and 4, and 5. You have, you have 0, 1, 2, 3, 4, and 5. 0 is not mapped. So option D is also wrong. So those are the two things to check for. Number one, the input must have an output. Each input must have one output. Then second of all, each input must have an output. That is, each input must have only one output and they must also have an output. That is, they have to check for those two things. Okay. Question one is C. Question two now. What is the codomain of the function f map from A to B? Defined by A map to 1, B map to 3, and C map to 5. Where A, the set of A, is equal to A, comma B, comma C, and the set of B is equal to 1, 2, 3, 4, and 5. They asked us what is the codomain. Let me explain what range, codomain, and domain is. The domain of the function is the set of inputs. That is all inputs that the function takes. If you are a car dealer, you are going to be importing car parts. You are going to be exporting or giving out cars. You are importing car parts, you are making the cars, and you are going to give out cars. That's what the function is. The domain is the input, that's what you are importing from abroad. Then the output, whatever you are resourcing, your input, you don't get from your local, if you are buying from your local craftsman, whatever you are importing, whatever you are imputing, not basically, but whatever you are imputing, whatever you are imputing into your warehouse, whatever you are buying, whatever you are buying, your domain is whatever the car dealers are buying. Then your output are not the cars that you're making. You are making truck, you're making cars, you're making bicycles, you're making whatever, all the automobiles, you're making them. That is your output. But then inside your output set, right? You can also choose if you want to sell biscuits. That only if you work in Rolls Royce, you can choose that okay, Rolls Royce can have their own biscuit company where they are selling the biscuits that they make. You can choose to have a floor mat company, just put your logo there, say yeah, you have a Rolls Royce car. Maybe you want to have make your house so that people know that yes, you have Rolls Royce. You can decide to make your floor mat, that's your welcome mat in your house, a Rolls Royce mat, so you can buy it for more cost. You understand? Just because you're a Rolls Royce company doesn't mean you're only going to be selling cars. You can decide to sell other things. Good. So now your output set, right, must not always be mapped. That's what I'm trying to say. In your output now, let's see this 1, 2, 3, and 4. 1, 2, 3. 1, 2, 3 now can be the cars you are selling. That is 1, 2, 3 represents that is if I give you my list of payment, list of transactions I've had, and you're saying that okay, I'm buying doors, I'm buying seats, I'm buying engines. Okay, the person that comes to head is okay, this person is making cars. So this 1, 2, 3 represents the output that a normal person would think I have. That's just the range of products. Then 4 and 5 are not like the extraordinary results. They are part of the good domain, but they're not part of the range. They are like the biscuits that Rolls Royce sells. It's not part of their range of products. So this 1, 2, and 3, which are mapped here, 1, 3, and 5, no 1, 2, and 3, 1, 3, and 5. So this 1, 3, and 5 are basically your range, the ones that the function stands for, the ones that inputs are mapped. But 2 and 4, they are part of the code domain. They are part of the things that Rogers are selling, but not necessarily what they are importing from. Good, okay, I believe I've tried my best to explain this as good as possible. So now let's solve the question. In the question now, we have seen that A, B, and C they are mapped to something, and that A, B, and C correspond to your domain set. So that is good to go. As long as all your domains are mapped, you are good to go. This is a function. So now if you check your output set, the range is 1, 3, and 5. So this is going to be option A is going to be answer, which is 1, 2, 3, and 5. Number two, option B. Your domain set are your inputs. Your domain set is your input or your this where all your input lie. Your codomain set are not necessarily your output. Instead, your codomain set are your possible. I believe this is a better way of putting it. Your possible outputs. Then your range set are your outputs in line with your input. These are the outputs that have an input attached to it. I believe this is a better way of using the cap part. But okay, if I find any better way of explaining this, I would do that.
You walk out of math class and find yourself struggling with domain and range from functions. Luckily, your friend is there and he tells you that the domain just specifies the x values or inputs of a function, whereas the range specifies the y values or the outputs. He then shows you a drawing of this quadratic graph and tells you that for a quadratic function, there usually aren't any restrictions on its inputs. Therefore, the domain is XER or all real values. Then he tells you that since there is a minimum point at the coordinates 1, 1, the smallest y value on the quadratic is 1. Any y value bigger than 1 also exists, so the range is y is more than or equals to 1. He also tells you to follow Isaac for more math tips.
Every graph has two shadows. One falls on the x-axis, the other falls on the y-axis. Watch. Take a parabola, y equals x squared. Drop the graph straight down. The shadow it casts on the x-axis is the domain. For x squared, every real number works, so the domain is all real numbers. Now slide the graph straight to the left. The shadow on the y-axis is the range. The y values never go below 0, so the range starts at 0 and goes up. Now try a different shape, square root of x. Square root only works for non-negative numbers. So the domain starts at 0 and goes up. And the y values also from 0 up. Here's the surprising one, sine of x. Sine takes any real number for x. But look at the shadow on the y-axis. Sine never escapes between -1 and 1. Unbounded input, bounded output. The shadows tell the whole story. Two shadows, the whole story of a graph. Follow at Daily Math Visuals for daily visual math. And check out the shop.
Okay, question 3 now. Question 3 is if f of x is equal to x, we have f of x is equal to x divided by x plus 1. Then we should find f of a over b divided by f of a over b. There's no really more to solve here. As long as f of a over b is not equal to 0, then f of a over b divided by f of a over b is not equal to 1. So the answer for this option D. But let's just say they don't tell you to find f of a over b divided by f of a over b. What if they ask you to find f of a over b divided by f of b over a? In that case, you would need to solve. You're not going to assume that it is equal to 1. You need to solve. So let's do that. Instead of f of a over b, instead of f of a over b divided by f of a over b, let's find f of a over b divided by f of b over a. That I'm just solving this in this way just in case the question, like in case you see this type of question again and you change it to be in this form. So you will not just assume that it is the one. That's why I'm solving this. Okay, so if f of x is equal to x divided by x plus 1, then f of a over b, let me change my then f of a over b is going to equal to a over b divided by a over b plus 1. Everywhere you see x inside the function, you are going to put a over b, then plus 1. So now let's simplify. The numerator will be here, a divided by b, divided by the numerator will be here, a divided by b plus 1. So here you have a divided by b divided by this a divided by b. Now you can bring everything down to have the same denominator. So this is b here. B divided by b is 1. 1 times a, that is a. Plus b divided by 1 is b. B times 1, that is b. So you have a divided by b divided by a plus b divided by b. So this now comes a divided by b times b divided by a plus b. The b here will cancel b here, and this will equal to a divided by a plus b. Good. So f of a over b is going to equal to a divided by a plus b. There's no need for me to solve for the second case, because I know that if f of a over b is going to equal to a divided by a plus b, I know that f of b over a is going to equal to b divided by b plus a, which is same thing as b divided by a plus b. That's I just say let a equals to b and let b equals to a, so that I can just change the variable without needing to solve the whole thing again. So if f of a over b is equal to a divided by a plus b, the f of b over a is going to equal to b divided by a plus b. So f of a plus a over b divided by f of b over a is going to equal to a divided by a plus b divided by b divided by a plus b. A plus b or cancel plus b and you left with a divided by b. So if they give you the question as f of a over b divided by f of b over a, the answer will be a divided by b. That also means that if they give you f of b over a divided by f of a over b, your answer is equal to b over a. Okay, so I believe I've done just this. The answer is actually still 1 because, as always, just because you think something should be that doesn't mean that that's what you give to solve. Just because you think that the question should be f of a over b divided by f of b over a doesn't mean that that's what you give to solve. They do it find f of a over b divided by f of b over b, and that's equal to 1, option D. Let's go to question 4 now. Question 4 says we should find the domain of the function f of x. If f of x is equal to 1 divided by the square root of x squared minus 3x plus 2, the domain of this function would be the whole set of real numbers minus the critical point. The critical point of this is when you have something that is not a real number. That's basically, we don't like anything that has to lead towards infinity. So we really don't want anything to have to do with 1 divided by 0. We don't want anything to have to do with square root of a negative number. We don't have anything to do with anything that does not involve a number that is either 0, a number of x less than or equal to 0. So let's solve. Your critical point here, right, at the point for this particular question is the point where you have 1 divided by 0. Because here there's no logarithm, here there's no nothing. Because there's actually square root here. Okay, but let's start with this. You have 1 divided by 0. You don't want 1 divided by 0. That means the square root of x squared minus 3x plus 2 should not equal to 0. This is your first parameter. Square root of x squared minus 3x plus 2 should not equal to 0. The second thing we don't want square root of the negative number, but there's a square root here also. So we don't want square root of a negative number. That means x squared minus 3x plus 2 should be greater than or equal to 0. It should be greater or equal to 0. This is our second parameter now. So now let's try to join it together. First of all, square root of x squared minus 3x plus 2 should not equal to 0. This implies that x squared minus 3x, this implies that x squared minus 3x plus 2 should not equal to 0 because the square root of 0 is 0. So the square root of x squared minus 3x plus 2 should not equal to 0. And x squared minus 3x plus 2 itself should also equal to 0. Good. But in our second parameter, we have something similar. We have x squared minus 3x plus 2 should not be less than 0. That means in this our second parameter, it can be equal to 0 because square root of 0 is 0, which is a real number. It can be equal to 0. But now I want to join this our parameter, this one and two, because the two of them must be true. Two of them is an AND gate. This must be true and this must also be true. It must be an AND gate. That is, two of them must be true. So it's not this or this, it is this and this. Okay. So if the first parameter is x squared minus 3x plus 2 is not equal to 0, and the second parameter is x squared minus 3x plus 2 is greater than or equal to 0, then we have joined them together and cancel out this equal to. So now we have x squared minus 3x plus 2 should be strictly greater than 0. No more equal to again because this parameter here, the first parameter say nothing should not equal to 0. X squared minus 3x plus 2 should not equal to 0. The second parameter says it can be greater than or equal to 0. So if we want to join them together, we are going to clean that equal to sign. It should not equal to 0. It should be strictly greater than 0. So now let's solve this quadratic equation. We have x squared minus 3x plus 2 is strictly greater than 0. If you factorize this x squared minus 3x plus 2, you have x squared minus 4x plus x. No, this will not work. X squared minus 4x plus x will not work. You have x squared minus 2x minus x plus 2. Yeah, this is better. You have x squared minus 2x minus x plus 2. You still don't have to factorize, then you use online formula. Okay, you have x here, bracket equals x minus 2 minus 1 bracket equals x minus 2 should be greater than 0. You have x minus 1, let me write that one. You have x minus 1 times x minus 2 should be greater than 0. Okay. The second thing to do now is your analysis. I don't really know what they call this in math, but it's like you're trying to check your turning point when is x minus 1 times x minus 2 greater than 0, when is x minus 1 times x minus 2 less than 0. That's what I'm trying to check here. So you draw this table. Let me draw in order not to this map, let me just draw it. In order to reach this, draw it here. Yeah, I think this way is right now. Before I used to draw that table entirely, but to save space in my software, I just to draw them together. Okay. So for the first one, we have x minus 1, that means x is equal to 1 at this point. We have x minus 2, that means x is equal to 2 at this point. The one that is lesser is x minus 1. So we have x should be less than 1. That is, the set is x less than the lower number. We have lower number less than x less than the higher number. And we have x greater than the higher number. Okay, so you have x less than 1. You have 1 less than x less than the higher number, which is 2. And then you have x is greater than. Okay, if x is less than 1, then x minus 1 will be less than 1 minus 1, which is that x minus 1 is going to be less than 0. This number is going to be a negative number. Here we have negative. If x is less than 1, then x minus 2 will be less than minus 1. That means here will be a negative number. If x is between 1 and 2, then x minus 1 will be between 0 and 1. That means x minus 1 here will be a positive number. If x is between 1 and 2, then x minus 2 will be between minus 1 and 0. That means here will be a negative number. Because minus 1 is less than 0 and 0 is less than. No, because minus 1 is a negative number and 0, and x is less than 0 is a negative number. So that the range of x will be a negative number. If x is greater than 2, then x minus 2 will be greater than 1. So x is greater than 1 is positive. Actually, anything greater than 0 is positive, but 1 is greater than 0, so anything greater than 1 is also positive. You have if x is greater than 2, then x minus 2 is greater than 0, and x minus 2 will be positive here. The product now, minus times minus is positive. Plus times minus is negative, plus times plus is positive. We're looking for greater than 0. That means we're looking for positives. These are the two positives here. That is when x is less than 1 and when x is greater than 2. Okay. So now, how do we now find this instead? You can either write this as x is less than 1 union x is greater than 2, or you can write it as since x is less than 1, then you have a lower bound for x. X should not equal to minus negative infinity. So you have negative infinity is less than x, which is less than 1, union x is greater than, or rather, let's turn it around. You have 2 is less than x. X is greater than 2, that means there's no upper bound. We have to have an upper bound, which is positive infinity. So 2 is less than x, less than positive infinity. Good. So now let's write this down using brackets. Since minus infinity is less than x, strictly less than x, not less than or equal to, then you are going to use circle bracket negative infinity, comma. Since 1 is strictly less than x and not less than or equal to, then it's going to be negative infinity, comma, 1, curly bracket again. Union, the same thing happens here, 2, comma, positive infinity. So now we have minus infinity to 1 not included, union 2 to positive infinity, 2 not included. And this corresponds to option C. Number 4, option C. As I have noticed, option A is totally wrong. Option B was put there to confuse you because option B is intercept. The intercept from negative infinity to 1 and from 2 to infinity, that's an empty set. There is no number that is less than 1 and not and greater than 2 at the same time. The number cannot be less than 1 and greater than 2 at the same time. So that number has to be an empty set. Okay? Number C now is the correct option. And option D is actually wrong because option D omitted this first parameter. Option D omitted the fact that x squared minus x plus 2 should not equal to 0. He omitted this fact. So he had square bracket instead of curve bracket. Okay? We have 1 more minute to 5, so okay, this is the continuation. We'll go again because I was not checking the recording and it got corrupted before the recording finished. So all the recording from question 5 to question 10 are not useful. So I've deleted it and I'm starting from beginning. So we have question 5 again. If f of x if f of x is equal to x divided by the square root of 1 plus x squared, right? What's the value of, or we should compute f of x. Okay, I explained in the other recording that f of x is a function. F of x is you are putting that function, that answer you got in the first function, into the function again. F of x, you are putting it again the third time. So I don't want to explain again that it mustn't always be it mustn't always be f of x. It can also be f of g. If you have two functions, they are finding the composite function of those two functions. They are first of all going to have the first of all going to get the value of f of g before you put inside the value of f of x. So in this case now, this is not the case we're giving. The case we're giving now, we're having f of x. So it's not f of another function, it's f of that same function. So when you have f of x, you already have what f of x is. So I'm going to put this value of f of x into itself. We are going to put this value of f of x into itself. So f of x is going to equal to f of x divided by the square root of 1 plus f of x squared. I'm very sure this is intuitive. Whatever you see inside the bracket is your value of x. So you replace everywhere you see x here, you put f of x. Whatever you see inside the bracket, which is f of x, you replace all the x's here with f of x. So you have f of x divided by the square root of 1 plus f of x squared. Good. Now, this is not the most simplified because this function is in terms of x. It's not in terms of f of x. So you have to simplify by changing all the f of x to the function itself, to x divided by square root of 1 plus x squared. So here we have f of x equals f of x divided by the square root of 1 plus f of x squared. F of x is equal to what? F of x is equal to x divided by the square root of 1 plus x squared divided by the square root of 1 plus f of x squared. Now, whenever you see f of x, you're going to square it. You have f of x squared, yes, equals x squared divided by the square root of 1 plus x squared all squared, which is something as just 1 plus x squared. Because square root, cancel out the square. Okay. Now, I want them to be the same denominator. So, what do? This one here, change it to 1 plus x squared divided by 1 plus x squared. I believe you understand that. You have a divided by a is equal to 1. So 1 plus x squared divided by 1 plus x squared is also going to equal to 1. So now you can now join the denominators together. You can just merge them into one denominator. And then you have plus here. So 1 plus x squared is going to give you 1 plus 2x squared. So you have x divided by the square root of 1 plus x squared divided by the square root of 1 plus 2x squared divided by 1 plus x squared. This division sign here will flip whatever is by the right hand side. Remember, if you have a divided by b divided by c divided by d, this equals a divided by b times d divided by c. Whatever you have behind the division will flip, and that division will change to multiplication. Okay? So here you have this is equal to x divided by the square root of 1 plus x squared times the square root of 1 plus x squared divided by 1 plus 2x squared. This here is inside square root. This here is inside square root. So you can multiply, you can cancel them out. So all your answer will equal to x divided by the square root of 1 plus 2x squared. Because you have x as numerator here, and you have the square root of 1 plus 2x squared in the numerator here. So f of x equals to x divided by the square root of 1 plus 2x squared. But this is not the final answer. The still we should find f of x. So they are going to put this f of x into the function again the third time. So that's how you get the f of x, or the f cube of x. So that's how you get the f cube of x. Yeah, that's a very good notation. So you should maybe for mass Grammy. Yes, just give me mass Grammy or whatever they call mass Grammy. Okay. So when you have f cube of x, yes, I'm going to write that here. instead of all this. When you have f cube, oh no, I don't know. I think f cube of x is as f of x to the power of 3. I'm not really sure. So let me just write it normal way. But if f cube of x is not like the same way you have sine of x all square, the same as sine square x, put as a subscript. Yes, this actually looks like a clean way of instead of writing f of x, just write f substitute 3x. This looks sweeter to write, but I'm going to write it like this. So f substitute 3x is going to equal to f substitute 2 of x divided by the square root of 1 plus f substitute 2 of x all squared. Okay. Now what is f substitute 2 of x? That is same as f of x. So this f substitute 2 of x is going to equal to x divided by square root of 1 plus 2x squared. Okay, good. Let's simplify this now. This is equal to f2 of x divided by the square root of 1 plus f2 of x all squared. Okay, f2 of x is equal to x divided by the square root of 1 plus 2x squared divided by the square root of 1 plus f of 2x squared is same as 1 plus f of 2x all squared same as x squared divided by 1 plus 2x squared. Because here you have f of x. Let me just put, I believe you will understand it better if I use f of x instead of f2 of x. But because f2 of x is not standard math, it's just something I just created now. But okay, so I'm going to use f of x. So f of is equal to f of x divided by 1 plus f of x all squared. This is now equal to f of x divided by the square root of 1 plus f of x all squared. This is equal to x divided by square root of 1 plus 2x squared as we got previously divided by the square root of 1 plus x squared divided by 1 plus 2x squared. It is x squared divided by 1 plus 2x squared because remember you have to square this. X squared is equal to x squared. The square root of 1 plus 2x squared all squared same thing as 1 plus 2x squared because the square root to cancel out the square. I believe that is understood. Okay, now we also want to bring this into the same denominator. So this one here we're going to change it to 1 plus 2x squared divided by 1 plus 2x squared. Okay, since we have the same denominator, we can now join the denominators together. So you are going to join the denominators together here. You have 1 plus 2x squared here. So here you have 1 plus 2x squared plus x squared. This is equal to 1 plus 3x squared. So here you have x divided by the square root of 1 plus 2x squared divided by the square root of 1 plus 3x squared divided by 1 plus 3x squared. Confusing, right? Well, let's simplify. Remember, if you change the division sign to multiplication and you flip the right hand side. So let's flip this. If you flip that, you're going to have the square root of 1 plus 2x squared divided by 1 plus 3x squared. 1 plus 2x squared here will cancel 1 plus 2x squared here. And you're going to be left with x divided by the square root of 1 plus 3x squared. And this is our answer, option D. Option D. F of x is equal to x divided by the square root of 1 plus 3x squared. Now I'm not sure if the camera is able to see everything. Okay, but we have f of x equals x divided by the square root of 1 plus 3x squared. Okay, use option D. Let's go to question 6 now. Question 6, as I said when the first recording, before that one got corrupted. Question 6 was solved in the past. That is mass MTH 122 20. I think this is right. MTH 122 24 plus 25. I think it's 25 26. Yeah, 24 plus 25 test 1 review. Question 6 was solved there and we got option B. Okay, what am I saying? Option B. And we got option B. Okay? We got option B. That is from negative infinity to 1 from 1 to 4 and from 4 to close to infinity. 1 and 4 not inclusive. Okay. Question 7. So if you want to find out how to solve this question, please go on to that question. So I'll not make so you not too long. Go to that past video and learn how to solve it. So I'll not be solving it multiple times. Just go and learn how to solve it from there. So question 7, we also solved it in that last video, the past question. Question 7 was option B. That's option 1. That's number 1. The answer is 1. That's option B. Question 8 is option A. This is also a past question. Question 9 is also a past question, and this is option. No, question 9 is not a past question. Question 9. No, question 9 is not a past question. So you have 6, 7, and 8 are past questions, and option 6 is B, option 7 is A, and option 8 is A. Okay. Good and fine. You will find them in MTH 122 2024 and 2025 test 1 review, which is already on my YouTube channel. It was uploaded since before the test. We wrote our own test. It was uploaded. So you can go and find out how to solve that question here. Yeah. Let's move on to the next question. Question 9. We should evaluate the limit as x tends to infinity. Okay. We're evaluating the limit as x tends to infinity of 3x minus 1 times 4x minus 2 divided by x plus 8 times x minus 1. Okay, as I explained in the other video that I created a video once. This video I created was on demand. That is a lady in industrial physics. So I should create this video explaining how to easily solve functions in the form of sine ax divided by bx. Okay, I realized that sine ax divided by bx as x tends to infinity is always going to cut a divided by b. And I showed you who the proof in that video. Okay. Now again, I come again with another proof. Just go to your question. Let's start for Roko. I'll do that later. Just go to your question. Pick the numerators. Carry your numerators. Do some arithmetic with them. That's a standard arithmetic. But let's solve this normal way. To solve this normal way, you have to first of all expand the numerator and expand the denominator. Okay, to expand the numerator, you are going to get 12x squared minus 6x minus 4x plus 2 divided by x squared minus x plus 8x minus 8. This is equal to 12x squared minus 10x plus 2 divided by x squared plus 7x minus 8. This is equal to x squared bracket open 12 minus 10 over x plus 2 divided by x squared. What did I do here? You guessed correct. I factor out x squared from the numerator. You factor out x squared from the numerator also. So you have x squared here, bracket open 1 plus 7 over x minus 8 divided by x squared. Good. Now you can plug in your limit, or before you plug in your limit, there's x squared here. So you can cancel out x squared here and cancel out the x squared here. Because you 8 divided by 3, you can cancel them out, is equal to 1. So now you can plug in your limit as x tends to infinity. As x tends to infinity, 10 divided by x will tend to 0. As x tends to infinity, 2 divided by x will tend to 0. The same thing happens here. This tends to 0, and this here tends to 0. So all you're left is going to equal to 12 divided by 1, which is equal to what? 12. The answer is 12, which is option D. Option D. Yes, option D. Now, this method was something I just created. I just not created, but I just saw that this method would work when I was recording this video just 3 minutes ago. But this doesn't show you the method I used when I was solving. The method I used when I was solving, okay, relies on separating this. Like, since we have AB divided by CD, I just carry A divided by C, multiply U with B divided by D. Good. So we have 3x minus 1 divided by x plus 8 multiplied with 4x minus 2 divided by x minus 1. I didn't know that. I didn't know that first one I showed you will work. That's why I use this method. But I realized just as I was creating that video today that this method actually will work. That first method will actually work. But the other should be the method I may use in the test. Okay. The same thing you do here. You factor out x squared there. Here I'm going to factor out x. Me, I'm used to factoring out only x. I've never factored out x before. But I've only factored out x. But I realized okay, you can also factor out x in the quadratic. But me, I'm used to factoring out x only in the linear function. But this is the linear function. Stress minus 1 is the linear function. I've never factored out x squared in the quadratic before. So, it's my first time, so I was a little bit worried. Will the thing work? Will the thing not work? I didn't want to waste time doing this, so I just used this method. Okay, so when you factor x from numerator, you have to have x bracket 3 minus 1 over x divided by x bracket 1 plus 8 over x. The other side, you are going to have x bracket open 4 minus 2 over x divided by x bracket open 1 minus 1 over x. All I did was factor x from all the brackets. So now you can cancel out your x's. The x will cancel out the x here. The x will cancel out the x here. So now you're left with 3 minus 1 over x. You can see what is on the board. But let me just say the case my is not that clear. You have 3 minus 1 over x divided by 1 plus 8 over x times 4 minus 2 over x divided by 1 minus 1 over x. As x tends to infinity, a divided by x tends to 0 as long as a is not infinity. Any number divided by infinity is going to equal 0. So 1 divided by infinity here is going to equal 0. A divided by infinity here is going to equal 0. Minus 2 over x divided by infinity here is going to equal 0. Minus 1 over minus 1 over x is equal to 0. They all tends to 0. So you are now left with 3 divided by 1 times 4 divided by 1. This also equals to 12. Whichever method you use, you're going to have 12, which is option D. 10. I'll do question 10 before I go for roll call. If I meet roll call, you will buy from this picture of you. Question 10 now, we have the limit as x tends to infinity of 2x plus 2 to the power of 40 times 4x minus 3 to the power of 5 divided by 2x plus 4 to the power of 45. Good. I don't know, thank God that I saw that method, the method I used to solve that last question 9. I don't thank God I saw that method before I saw this question. Because I saw this question, I should not giving up because I did not want to start expanding the words. That last one we expanded before we applied our laws of before we applied our mass. We expanded first of all. Imagine raising up to power of 40. That is not possible. Or it's possible, like it's famous. We cannot do that in a limited time. So I don't thank God that I actually saw that method, the previous method that I used to solve before I saw this question. So now let's do some thinking. We have power of 40 here, we have power of 5 here. Add them together, that's power of 45, right? Good. We cannot just add these two together because of the base here is different from the base here. But we can separate this 45 into two components. Since we cannot bring two families together to form under one roof, then you form one house, divide that house into two, and then the two families share. I will say that again. You have two families, family A and family B. They don't want to live together, they don't want to live under one roof. Then instead of living forcing them to be inside one roof, you build two separate houses for them. You can even build the same house for them and then divide the house into two. Tell them that okay, this part is for you, the kitchen is for you. Let them sort themselves out, divide it into two for them. Good. Anytime if you cannot bring these two families together, the two families numerator together, then this house in numerator, you divide it into two for them. Good. So this first part, we have 2x plus 2 to the power of 40 divided by 2x plus 4 to the power of what now? What will I say? It's not power of 40 again, because how would two human beings, be sharing more than 2 rooms, be living in more than 2 rooms? I cannot be living in 2 rooms. I only need 1 room to live in. So how will 40 people now go and take 41 rooms? No, they need only 40 rooms. Share it peacefully. Multiply. You have 4x 4x minus 3 to the power of 5 divided by 2x plus 4 to the power of the remainder, which is 5. So let's continue. The same way we did that last one, you can now join this into one family. I told you, see that I've separated the house into two. You can join them inside the same house. So this is now going to be 2x plus 2 divided by 2x plus 4 to the power of 40. This is actually a law of indices. A to the power of m divided by b to the power of m is equal to a divided by b all to the power of m. times, the same thing happens here. You have 4x minus 3 divided by 2x plus 4, all to the power of 5. Good. Let's factor out x from here. Now we're dealing with what's inside the bracket. Let's factor. Now we don't really want to care about the power. Leave the power for now. Let's factor out x from here. If you factor out x from here, we are going to have x bracket open 2 plus 2 over x divided by x bracket open 2 plus 4 over x. Not 4 over 4, 4 over x. Okay. Bracket close to the power of 40 times. The same thing happens here. We have x bracket open 4 minus 3 over x divided by x bracket open 2 plus 4 over x. Bracket close to the power of 5. What happened the last time? The x is cancelled out. The same thing happens now. The x is here, cancel out the x here. The x here, cancel out the x here. What happened again? As x tends to infinity, a divided by x will tend to 0. So 2 divided by x here tends to 0. 2 divided by x here, 1 divided by x here tends to, number 1, 4 divided by x here tends to 0. Minus 3 over x here tends to 0. And plus 4 by x here also tends to 0. So all we're left with is 2 divided by 2. Let me clean the top here. So all we're left with here is 2 divided by 2 to the power of 40 times 4 divided by 2 to the power of 5. 2 divided by 2 is something as 1 to the power of 40. 4 divided by 2 is something as 2 to the power of 5. 1 to the power of anything is 1. So 1 to the power of 40 is just 1 times 2 to the power of 5 is 32. So 1 times 32. This equals 32. Let's put a box around that. 32, and that's option C. So what did you mean I solve this using L'Hospital rule? That was actually work. That work. L'Hospital rule work. Yeah. So I was just thinking that okay, L'Hospital rule, does that mean you have to expand everything? Like you need to expand all the brackets. But I just realized that no, L'Hospital you don't need to expand all the brackets. For L'Hospital rule, when you're differentiating, you can just use your size everything. But yeah, I don't really use L'Hospital rule because I don't think L'Hospital. Honestly, I don't think L'Hospital rule will make everything work 100% simple. I think after you differentiate, you have to differentiate again and again and again, like 45 times to make sure that you always have okay, maybe not for maybe if you cancel for S then you're going to do it for 42 times. So the style rule is actually not the best option. I think the best option actually to follow this method. So but those people that say they lose the style rule, I hope you got the correct answer. Let's not be as if you use the style rule now. You will not make some kind of small mistakes, think that you are correct. Don't know that you actually mistakes. But let us move on next question. Or I promise I'm not never gonna do roll call first of all before I start to get my decision. Okay. Back to roll call. Question level. Level is a work question, so I always solve for that. Question level is a work question. Question 12 is a work question. Then we'll solve question 13, 14, and 15. And we'll call it a night, not a day. Question 11. Which statement correctly distinguishes between f of x plus h minus f of x all divided by h and the limit as h divided by 0 of the previously stated expression? First of all, remember, in fact, I'm not going to answer this. I'm not going to explain this question. Mr. Bola explained this question deeply. Talk about it deeply in class. That one of them is, I don't know, I've forgotten name because it was like average. I believe one of them is the average of two numbers of like the second line. I believe that is what they call it. One of them is the second line. That is I believe you can see the board from here. Yes, you have a graph like this. You have this point here, you have this point here. So you have the second line that passes here. So one of them is graded of that second line is basically the middle of that second line. Then the second one is the tangent of this line. That second line is tangent that is only one point, it has 2 points. Explain this deeply. One of them is basically the average of those two numbers. Is the average they call it? I believe okay, it's the average rate of change. One of them is the average rate of change. Why the second one is the derivative. So option B is the correct answer. Both are derivatives, the first one is not derivative. The second one depends on average rate of change over a small interval. That's correct. Why the second is derivative if the limit exists. That's correct. Question C, the first is the tangent slope. No, the second is the tangent slope. While the second is the second slope. No, switch them. The second is the tangent slope, while the first one is the second slope. Okay. So option D, the first is defined only for linear functions. They are defined for all functions. E of x, f of x, sin of x, all functions. Why the second is defined for all functions? No, they are both defined for all functions. Okay. So option question 11, the answer is option B. The first is an average rate of change over a small interval, while the second is derivative if the limit exists. The second way they can put this question right is if they tell you the first is the second slope, while the second is the tangent slope. Then that's also correct. But in this case, remember to switch them. In this case, the first is the tangent slope, while the second is the second slope. Now that's why it's wrong. But yeah, question 11, option B is the correct answer. Question 12 now. The function f of x is equal to the absolute value of x is not differentiable at x equals 0 because now for something to be differentiable, right? Then the derivative at the left hand side must equal the derivative at the left hand side. For something to be continuous, then the limit at the left hand side must equal the limit at the right hand side. A function can be continuous but not differentiable. If something is differentiable, then it must be continuous. But if it's continuous, doesn't necessarily mean that it's differentiable. Don't mix them. Okay. For something to be a human being, no, let me start from you. For something to be a woman or a female, it must be a human being first of all. Hey, no. They're actually female goats. But okay, for something to be a woman, because don't I'm very sure of this that you don't call it a woman goat, you call it female. Female is generally for all the people that are the vaginal bearing people. But women on their own, I feel women is directly linked to human beings. So for something to be a woman, he must, okay, let me just say something. For someone to be a woman, she must first of all be a human being. But if someone is a human being, it doesn't necessarily mean that person is a woman. The person can also be a man. Let's wait for this question. If a function if a function is continuous, it doesn't necessarily mean that function is differentiable at all the points. But if a function is differentiable, then it's continuous. You understand? So the variable is like the subset from that continuous. If it's continuous, then you can, okay, let me just like if it's continuous, it breaks down to differentiable and non-differentiable. So continuous is the first thing you should check. If that function is continuous. If it's continuous at that point, then good and fine, it's continuous and it may be differentiable. But if you check if it's differentiable at all the points, then it must be continuous at all the points. So if differentiability is below continuability. I don't know if the English word I'm saying is correct, but I'm very sure that differentiability means implies, yes, that's the master term. Differentiability implies continuability. Now I'm not sure if continuability is correct English, but I believe that's what I'm talking about. Okay, differentiability implies continuability, but continuability does not directly imply differentiability. I gave an example of something like this using human being and woman. Let me give you another example. This is the example I gave in the textbook I'm writing. In that textbook, I gave the example that if rain fell, it means the ground will be wet. But if the ground is wet in the morning, it doesn't necessarily mean that rain fell. And I said this in the book, it was a joke, but it was funny in my head. I don't know if it's funny to you. And after that, maybe your neighbors just watch their keke napep in front of your house. That's like maybe your neighbors at night, you know, to watch their keke in front of their own house. Now go to your own house and watch in front of your house, and that is water in front of your house. But yeah, it was funny in my head, but it's not more funny again because I tried, you know, they're laughing. But question 12, question 13. Okay, let one start question 12 now. If the function f of x is equal to absolute value, is not differentiable at x plus 0 because f of 0 doesn't exist. No, f of 0 exists. F of 0 is equal to 0. That is the limit at the left hand side is equal to 0. The limit at the right hand side is equal to 0. So f of 0 is not equal to 0. The function is continuous at 0. No, the function is continuous at 0. Actually, because of the left hand side is for the left hand side limit is equal to 0 and the right hand side limit is equal to 0. So it's continuous at 0. The value of the function is negative to the left of 0. The value of the function is negative to no. absolute value of x is never going to equal to a negative value. It's always going to be positive. So that answer is not correct. Option D now says the left hand side, the left hand slope and the right hand slope are 0 and not equal. That is your answer. Now let me just give you a little bit explanation to why the left hand side slope is not equal to the right hand side slope. The derivative already as know is the slope of the function. But let me just give you an idea. Well, how does the absolute value of x look like? The absolute value of x looks like this. You have a slope of minus x coming from this side, and you have a slope of plus x at this point in time. At this point in time, we have seen that this point here is 0, 0. It's continuous at this point in time. But if you check the left hand side, the value of the derivative on the left hand side is equal to minus 1. The value of the derivative at the right hand side is equal to plus 1. You can see this is a graph of y equals to x. That means the gradient is plus 1. This is a graph of y equals to minus x. That means the gradient is minus 1. You can see that the derivative at the left hand side is minus 1, while the derivative here at the right hand side is plus 1. They are not the same. So at this point in time, it will not differentiable at this point in time. The gradient is not does not exist at this point here, 0, but it's continuous at 0, but it's not differentiable at 0. So let's go to the next question now, question 13.
Yeah, you still recording.
Question 13. Wow, beautiful question. Beautiful question. Okay. We have differentiate. If we are giving y is equal to x squared plus 2x all squared, I believe, all squared, yeah, divided by x minus 1. We should find the first derivative. This is a quotient rule because y is equal to, rather let me put that this y of x is equal to u of x divided by v of x. So if I find the derivative of y of x, this is equal to b square of x, v of x, the derivative of v of x minus u of x, the derivative of v of x. Basically, it's confusing here, but basically what I'm trying to say is just dy over dx is equal to u dv, is equal to v du minus u dv divided by v squared. This is basically what I'm trying to say here. So let's use this to solve this question. What do we need? We need the u of x, we need the v of x. That is differentiate numerator, differentiate numerator. That's basically what we need. So let's do that. Okay. Let u equal to x squared plus 2x all squared. Then the derivative of u is going to equal to, bring these two down. We have two. This is also going to be for the power rule, not for the this power rule. So we bring these two down. X squared plus 2x bracket 2 minus 1. 2 minus 1 is equal to 1, so that's 1. And x power 1 is just that. So you have 2 times x squared plus 2x multiplied by the derivative of inner function. The inner function is x squared plus 2x. If you differentiate that, you're going to have 2x plus 2. Now I'm solving this with the idea or the belief that the people watching already know how to do this. Please, if you don't know how to do this, please tell me in the comment and I'll create a new video explaining how to apply the addition rule, power rule, all the rules of calculus. But for now, I'm just going to do it as if you already know what this is. So you bring down the power. Someone made a song about this. Bring down the power, subtracted by 1. Actually, no song. I know this song. I just laughed about the song and then moved on. But so I believe it bring down the power, subtracted by 1. They multiply by the derivative of inner function. Bring down the power, subtracted by 1, multiply by the inner derivative. And the next, Michael Jackson, next, whatever big vision is out there. And the next XXX tentation. Yeah. So you have 2 times x squared plus 2x times 2x plus 2. Okay. Let b equal to x minus 1. Then the v is going to equal to dx. So now we have all our weapons to solve this question. So let's solve it. So dy dx is equal to v du minus u dv divided by rather dy is equal to v du minus u dv divided by v square. That is equal to x minus 1 times 2 bracket x squared plus 2x times 2x plus 2 minus bracket open x squared plus 2x all squared bracket open 1 divided by x minus 1 all squared. This is going to equal to x minus 1 times 2 is the same thing as 2x minus 1, 2x minus 2 times 2x plus 2 here times x squared plus 2x here minus you have x squared plus 2x here times x squared plus 2x. Because this x squared plus 2x all squared, so that's x squared plus 2x times x squared plus 2x divided by x minus 1 all squared. Let me clean this with space to solve now. This equal to 2x minus 2 times x 2x plus 2 is the same thing as 4x squared minus 4 times x squared plus 2x minus bracket open x squared plus 2x times x squared plus 2x all divided by x minus 1 all squared. Now as you get it, we can factor out x squared plus 2x from the numerator. So let's factor out x squared plus 2x from the numerator. You have x squared plus 2x bracket open 4x squared minus 4 minus bracket open x squared plus 2x. This is equal to x squared plus 2x bracket open 4x squared minus x squared is equal as 3x squared minus 2x minus 4. And this corresponds to option B. Okay, divided by, don't forget, divided by x minus 1 all squared. So we have x squared plus 2x times 3x squared minus 2x minus 4 all divided by x minus 1 all squared. And that corresponds to option D. And that's the correct answer, option D. So let's go to the next question now. In case you have money, you can tell your father to buy for me bigger board in case you want to complain. But for now, this you can go to manage. The next question is question 14, which says if y is equal to the square root of 4x squared plus 9, you should find the first derivative. Y is equal to 4x squared plus 9, find the first derivative. Okay. So what do we know about this? To find the first derivative, I'm not going to apply first principle or anything. The derivative is going to equal to, okay, no, let me just rewrite this y. Y is equal to 4x squared plus 9 to the power of half. Write indices. Don't forget this one by sang. Bring down the power. Subtract it by 1. Multiply by the derivative of the inside. The derivative of the inside is equal to 8x plus 0. That is 8x. So bring down the power. Subtract it by 1. Multiply by the derivative of what's inside. So 4x squared plus 9. If you differentiate that, you're going to have 4 times 2 times x to the power of 1. That's 8x plus 0. So that's going to be 8x. So bring down the power. Subtract it by 1. Multiply by the derivative of what's inside. So this now is equal to 1 over 2 times 4x squared plus 9 to the power of minus 1 over 2 times 8x. 1 over 2 you'll cancel out 2 from here. That's going to give you 4x here. Okay, this is going to equal to 1 divided by 4x squared plus 9 to the power of half times 4x. This is multiplied by 4x, just bring it to the numerator here. So that's 4x. So this is going to equal to 4x divided by the square root of 4x squared plus 9. And this corresponds to option B. Corresponds to option B. So time for the last question before we call it a day, or rather a night. Okay, last question is an economics question. A firm's total cost function is C of x is equal to 2x squared plus 5x plus 100. You have 2x squared plus 5x plus 100. What's the marginal cost at x equals 10? T of x T of x is equal to 2x squared plus 5x plus 100. Okay, we are finding the marginal cost at x equals 10. We use first of all find the marginal function. Okay, the marginal cost of x is going to equal to the change in the cost price divided by the change in x. Okay, how do we do this? How do I explain this? But this here, the limit for each instantaneous change in marginal cost is going to equal to the derivative of the cost price or the cost function with respect to x. So you have change of cost divided by change in x is going to equal to the derivative of the cost function with respect to x. And this is equal to 4x plus 5. If you differentiate this, you're going to get 4x plus 5. So if you now plug in your function, you have at x equals 10, that is at x equals to 10, this will be 4 bracket 10 plus 5, which is equal to 40 plus 5, which is equal to 45. So your marginal cost x equals to 10 is going to equal to b 45. And that brings us to the end of this question. I believe you, or rather, I hope you learned something from here. If people have any further questions, you can ask inside the comments and I'll answer you. If the questions are too much and they need a separate video on their own, I'll do that. Thank you for watching this video. IgweMatics out. That kind of thing.